Hi, I'm going to be speaking about determination of molecular mass of molecules using colligative property measurements. One of the ways of finding out the molecular mass of molecules is to dissolve them in suitable solvents and then study the properties of the solution with respect to the properties of the pure solvent. So the properties which are studied are, first of all, boiling point, elevation. This means that the boiling point of the solution becomes higher than the boiling point of the pure solvent. Then we have freezing point, depression. This means that the freezing point of the solution decreases as compared to the freezing point of the pure solvent. Then we have drop in vapor pressure. This means that the vapor pressure of the solution is less than that of the pure solvent. And finally, osmotic pressure. Osmotic pressure is also represented by pi. So these properties in dilute solutions depend only on the number of molecules. Only number. And not on the nature of molecules. So this means they only depend on concentration. And also it means that the solutions of these molecules in the solvents are ideal solutions. An ideal solution is a solution in which the solute molecules don't interact with each other, nor do they interact with the solvent. So therefore these properties are called colligative properties. So we'll be speaking a little more about osmotic pressure. Consider a vessel like this, which is divided into two compartments by a semi-permeable membrane. This is a membrane which is called semi-permeable. Semi-permeable means it will only allow the solvent molecules to pass through it and not the solute molecules. So on one side of the membrane we have pure solvent, and on the other side of the membrane we have the solution. The solution of whichever molecule you want to measure in the pure solvent. It could be a polymer molecule, a high polymer, suitable, it could be a protein molecule, a large biomolecule, and so on. Okay, so now what is expected is that when you put this together like this, the solvent molecules will cross the semi-permeable membrane to enter the solution. And this process is called osmosis. This is osmosis. If we apply a pressure on the solution side such that this pressure is just enough to prevent the entry of solvent molecules into the solution, then this pressure is called the osmotic pressure pi. So this is the definition of osmotic pressure. It's the pressure you require to just prevent the entry of pure solvent into the solution. So once you measure this osmotic pressure, then the molar concentration of solute in the solution is given by osmotic pressure pi divided by R into T, where R is the universal gas constant and T is the temperature at which the measurements are made. This law is true for dilute solutions and it is used in colligative property measurements. And you can see from here, the osmotic pressure directly depends on the concentration in moles per liter. So this is a colligative property. So a simple way to find out the molecular mass using osmotic pressure, you take W grams of solute and mix it in V liters of solvent to form a solution. Then the second step, find out osmotic pressure of the solution using a suitable osmometer. Then the third step, apply the law M equals pi upon RT and find out moles per unit volume of the solution. The next step, find out number of moles N by multiplying molar concentration capital M by the volume V. This is number of moles. And finally, find out molecular weight MW by dividing the weight of solute taken by number of moles. So this is the way to find out in a simple way the molecular weight of a solute using osmotic pressure measurements. So comparing osmotic pressure measurements with other colligative properties. Other properties means boiling point elevation, freezing point depression, and drop in vapor pressure. Osmotic pressure measurements are highly sensitive and especially useful for dilute solutions. Other colligative property measurements are less sensitive and they are used for more concentrated solutions. Then the measurement itself. The osmotic pressure measurements require a semi-permeable membrane, and there are all kinds of issues with the membranes. The membranes get clogged, they have to be kept clean, and the solutions have to be ideal, only then they work, okay? And the other colligative properties, they have issues with measurement of small changes in small pressure and temperature changes, or let me write small delta T, change in temperature, and small change in pressure. And then there is also issues with overheating and supercooling. And finally, the application, osmotic pressure measurements are used for large molecules like high polymers and large biomolecules, and other colligative properties are used for smaller molecules. Thank you very much.